Hi there guys, this is for the chapter 16 video. Yeah, I'm back. See all this stuff? This is all that, in one way or another, one form, modified, played around with. This is your standard bell curve. As you can see, I got the 68% area, the 95% area, and the 99.7% area. So, one thing to get clear here is, technically speaking, when we say we're 95% confident, that is saying it is 95% of the area of this thing. See, because under the bell curve, from here to there is 95%, which also happens to be approximately 2 standard deviations, but in real life, it's actually 1.96. I don't know why the book doesn't even, I don't think the book covers this at all. I think this is important to understand, is that all the numbers we're getting from here are coming from a bell curve, which is why it keeps on showing up, but it doesn't cover area and stuff like that for some weird-ass reason. In any case, let's move on here. There's a couple of things you have to understand. Is 95, 68, 99.7. Notice those are the 3 empirical rules. 68, 95, 99.7. When we say confident, that's basically saying it's in the area under the bell curve, because the bell curve is an idea, oh, this is all the numbers we've got, this is how many of them go under this. The highest portion means the most number of items or people fall under there. That's the bell curve. So when we say we're 95% confident, we're saying 95% of the people in our sample fell in this area, which basically saying is that we're 95% sure it's going to be in there. You understand that? It's just taking the same information and just transferring it to a different area. Okay, let's move on here. Okay, there's a couple of different terms. You have to understand a couple of different abbreviations here. We got the margin of error, standard error, confidence interval. This is critical value, alpha over 2, which is equal to area. And you have confidence level. Remember what I was mentioning about area? Yeah, there is math involved in finding out going from area to the confidence interval. However, it just happens that 68, 95, 99.7 happen to be exactly the same in both area and confidence. Let's move on here. There's a couple of steps to approaching a problem. Okay, first step to approaching any problem in this is quite simply, is it an individual question? Is it biased? Do you remember that chapter? I think it was like chapter 10 or 11, bias, samples, and all that stuff. You're asking yourself, is there bias? Because if there is, you can just stop the question right there and just explain what kind of bias and why. The next step in starting the question is NP times, or plus NQ, sorry, it's NP plus NQ greater than or equal to 10? Simply, if it's not, if it's less than 10, you can stop, show the math for that, and that's it. You're done. No more. That's it. I hope he gives us a lot of questions like that on the quiz. And the last one is your sample size. Is your sample size less than 10% of the actual population? So if there's a town that has a population of 100 people, and I have a sample size of 20 people, that's 20% of this village or whatever. So I can't use this in type of normal model. I can't use it because it's 20%. It's not less than 10%. Therefore, I can just stop the question and say sample is too large. 20% should be 10%. Okay? These are basically the easy questions. If, also, very important, check, as was proven when he was reviewing the homework today, check if this works. Because if this is how it is, you're done with the question. You don't have to solve it. You just move on, explain why it's wrong. However, most of the time, you're going to get yes, 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 this all works. What do you do from there? First step, I like to break it into this process. First step would be to find your standard error. Now, most people would just jump to the margin of error. However, he might ask you about the standard area or the standard deviation. Those are equivalent. And that's just simply square root of p times q over n. Don't forget, q is equal to 1 minus p. I didn't have enough space here to... Actually, I did have enough space, but whatever. Q is equal to 1 minus p. We covered that last chapter. Okay, so he'll give you p, probability, which is the percentage, that value he gives you. Just do 1 minus that to find your q. N is just the number of the sample. That's it, how many people are in the sample. Then you find the margin of error, which is for 95%, remember 95% confidence right up there, you would either use 2 or 1.96. However, he wants you to use 1.96 for sake of getting the question right. Technically, you can use 2 on some questions. Just use 1.96. It makes your life about 100 times easier. Okay, 1.96, memorize it. You can find it in your calculator. I'm not going to show you how to find it in your calculator because if you just memorize it, you don't even need to do that at all. Okay, do 1.96 times the square root of PQ over N. This is why I drew that arrow right here to critical value from margin of error, because critical value is kind of the same formula. And we're going to cover that in a second. It's right here. Okay, and the last thing you'd want is to find your confidence interval, which is simply your p-value plus or minus the margin of error. Or, if you really wanted to, you can do the p-value plus or minus 1.96 times the standard error from right there. Okay, that's just to get your confidence interval, that area. And remember, whatever z-score you're using here, 1.96, comes from this. I wrote them down for your ease, I guess. The 68th percentile is going to be 1.645. The 95 is going to be 1.96. And the 99.7 is going to be 2.97. Okay? Just memorize those three. Okay? All you need to memorize. Besides the formulas, obviously. Okay. The last part is the critical value. I don't know if he's going to ask us about this. However, he needs to give you a z-score, or you need to find it in your calculator. You can find that in like chapter 3 or 4. You can find your z-score in your calculator. I hope he really doesn't do this. I hope he just gives you a z-score so we don't have to find it on our own. All you do, this is the exact same formula for this, except instead of being given the z-score through the bell curve, you have a random one. Just PQ over N, square root, times. That's it. Done. Same formula, just twice. And this one is just less specific, I guess. Last part is this alpha and alpha over 2 thing. This is basically if you're given an alpha and you're given you're given just a confidence level and you need to find the area. You need to find all this other stuff, all this rest of this information just from the confidence level. You just do 1 minus the confidence level equals alpha. Okay? Fair enough. Alpha divided by 2 is equal to the area. Then you get in your calculator here. Open it up, go to second bars, go all the way to, I believe it's like 8 or something. No, right there. 3. Why did I even do? Okay. 3. Click on it. Notice you're given an area. This little symbol here is your mean. This little symbol here is standard deviation. Standard deviation, that formula, you'll have those numbers. And mean is actually the number right in the middle. You're going to see like if this was labeled correctly, not with the standard deviations, it would be like 0.7, 0.3, 0.8, whatever it is. That number right in the middle, that's your mean. So plug them in to the calculator, click on paste, whatever. Click on paste at the bottom, and it gets you your answer you're looking for. Also, I prefer to use the formulas, but if you're more of a calculator kind of person, just go to stat tests all the way down to, where is it? Shit. It's alpha. Remember that. 1 prop z interval test. Click on it. X, that is your whatchamacallit value. N, that's your N. Confidence level. And just click calculate. And it does the work for you. It gets you your interval, it gets you your p-hat, and it gets you your N again. Again, formulas, infallible, plus he might ask you for shit in the middle. Okay? Calculator doesn't give you that shit in the middle. Just use the formulas, in my opinion. They're not that hard to memorize. Alright guys, good luck. Bye. Have fun.